Good day, guys. How are you doing today? In our previous lectures, we talked about the digital high-ho operations. We even carried out button operations with an Arduino Uno programming. But this time around, I decided to make use of the Nano Arduino, Nano from Arduino company. Then we're going to write the simulation code to put this. What is different in both using Arduino or Nano is the pin configurations we're going to point out, so you're not going to mess. Then what we're going to try out here is to use this today is the designing of analog circuit with rotating with a potentiometer, and then we're going to make use of it. We're going to use to control the volume, the LCD of the LED, and also the sound. Now let's begin. We're going to make use of SIM IDE and a PC sim laboratory for the carryout of the operations, design, and simulations. Then we're going to try it now. Let's jump let's jump straight into the circuit design first. From the circuit design first, then we have something like this. Let me just make it more zoom. Let me just start from beginning so that everything will be more clear. So just Control delete. Then this is my SIM IDE. You can download it if you have been following us before. Then from there you can just search for all apps. What we need a voltage source, we need a terminal, serial terminal for serial communication. We also need a Nano. We want to make use of Nano this time around, so make use of Nano here. We also need some LDE. We also need potentiometers. Then we need a potentiometer. We also need an audio signal buzzer, audio. Then we look for audio signal here. Then it's time for us to connect our LED. Then we have our LED this way. You can control how to rotate. Then you can drop some other LED. You can just have a Control C. Then Control Z. So Control R. Then you can also drop on that one here. Control R. So also drop on that one below it. So Control R. You can even duplicate it. Control C. And Control V. Then we move it beside it, and so 8 LED. Let's go to 4 8. 1 2, just 1 2 3 4 5. 1 2 3 4 5 6 7 8. Then we delete, so Control Z, we delete one of it. Then let's connect this pin. Let me zoom in. Before then, let me arrange them to their position. It still remain one of the components that is resistor, so that to measure up all the battery. Control Z. Then you can make use of individual resistor, but now I'm going to make use of DIP resistor. DIP resistor just is here. Sorry, it's not what I'm looking for. Resistor, DIP resistor. Make use of this resistor here. This is also 8 pins. Then I can increase the to 9 because I also want to know the resistor pins for another operation. Then I carry my buzzer output here beside it. Then we have our connections to our resistor. We first get our negative this to this side. So then we do the same thing for all this. Excuse me. Just want to make sure that everything is done. I would have designed it already. I think I even have it designed. I think I've once deleted it. So then We connect it to each of the individual pin of the resistor. We can also make use of the individual resistor, but now then we can go ahead. Then we have this. We have all the pins connected here. Then we can also have all our pins connected to this port here. We can just have them be from pin from this start from here, from our buzzer here. Be pin 10 for instance. The other one 9. So even some of the port pins are both for analog and digital. So I'm making use of the PWM for the, you can see the sign in Arduino programming. You can see the T sign beside some of the numbers here. That means either in Arduino, Omega, or any of the varieties of Arduino, is to tell you that this is PWM pulse width modulations. So it can also serve as both digital and also pulse width modulations. Also, these are the analog sections of the Nano. So I'm going to zoom in later when I'm through with the circuit design. Then after finishing, the reason why I'm going through this length is that I also want you to understand the connections. In the PLC sim lab, we're not going to go through all this. So to just do it once and carry the modules and join them together. Then I have this is my voltage source here. I'm moving towards this side. Okay. I came to one of the pins. Okay, one of the active low sensors then. So when we go for the high, mine and get it from the pin A0. So I connect my potentiometer to the pin 0. So I also use one component more, that is the ground. So I can search for it. I have the ground here. Okay. That's okay. We're almost through with the circuit design. So let me also connect my serial terminal here. The serial terminal is connected. The receive portion go to the transmit portion of the Nano. So the transmit also from the terminal go to the receiving end. So circuit there is then it will make the last part of this. I have my circuit here. So I ground the remaining pins to have the full circuit connection. So yeah, so so I have all the circuit connected now. I think our circuit is fine now. So therefore, you can also, if you remember, let me just put this one to 5 volts. You can start to use this analog voltage 5 volts. So you can also decide to make use of the phase voltage. You can search for it here, search for phase voltage. So you can see that this is just 5 volts. You can change it to any voltage you want by double click on either of the components and go to the properties. Case just 55 volts current volt. Can increase it, it will change the value. But 5 volt is okay for the Arduino. We go beyond that so that we don't damage the ICs than reward. So now let's try to save this. Let's try to save it now. We have saved this and let's try to go to our code. I don't know where my code is. located. Okay, my Arduino code. Here it is. Then we have our constant int, the LED pins, the port pins, the potentiometer pin is in the pin A not. Remember, I changed here to Nano. In case your one is showing Arduino, you can just select and search for Nano here. In case you use the live the tools, you can just, it will show the USB more board here that is connected, fully connected to the pin here, and then will be my bus pin. It was, let me check where I connected my buzzer pin. That is pin 10. So that's pin 10. So 10. Then what other thing here is my, okay, constant int, that is my LED pins. This array, so let's make use of array of what by default is going to calculate it. So then we have from which pin to which pin do we have it, from pin 2 to pin 9, from pin 2 to pin 9. So let me zoom in here a little bit. You see, from pin 2 to pin 9. Then we have then 2, 3, 4, 5, 6, 8, 9. Then the setup function is where we initialize all the pins. So you can also get a set of functions here. Before then, you can also calculate by default. Let's just get the length of, will be just assign int. That is array length. That is the length. Let's just name it as length equals size of the LED pins. You can just decide to just count the element in case it's not much, but I just want to get them automatically. LED pins divided by size of LED pins of any of the indices. With any of the indices, I just select to pick the first index, which is index 0, index 1, index 2. So how to get the length here? Sorry, length. Then let's initialize all the pins. Which one will be for input? Which one will be for output? So let's try to do that now. That is pin mode. The mode of the pin is called what? Our port pin. Potentiometer pin is analog value, so it's going to give us analog. So it's going to give us an input. It's going to be an input for us. So the pin mode for the analog, that's for the bus pin, is also what's going to be output. Then for all these pins, you cannot just be initializing them one after the other. So let's just create a for loop to do that for us. For int and int array index, let's see, index and LED index, equals 0, for instance. Then LED index is less than the length we declare here. Then we have a LED index equal to plus. Then we have it here. Then let's declare them as output, since they are outputting LED's output device. So let's output date. Now we make use of that's pin mode, our LED pins of LED of index, and its outputs. What are we trying to do here? We try to access them by index value. In case it's index 0, we fetch 2, index 3, we fetch 2, or we fetch index 2 in 1, we fetch 3, and so on until we get to index 7 here. Index 0, 1, 2, 3, 4, 5, 6, 7, which should be 9. Then let's save. Then we have it. Okay, now let's also, since we're also using the serial terminal here, let's also initiate our 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 serial communication. Serial dot begin. The baud rate we're going to make use of is Snapdragon 600. That is the baud rate. That is the baud rate. So something like baud rate. Then communication port. Then let's try to read the value of the LED int readings from the potentiometer analog. Since it's analog read, it's good to, we are reading from the pin. Where is the pin of the analog? Port pin connected to it. Then let's, okay, that's nice. So now let's try to look at some things. In ADC conversion, when you have the ADC at 10 bit, that means it's 2 what? 2 raised to power 10. That is from 0, that's 1024. From that is starting from 0. That will be our readings will start from 0 to 1023 to have to make up of 1024 bits. Then therefore the in Arduino also helps us with a function called mapping to be able to map all the values that we're going to get from the arrays. Then sometimes also we want, depending on our output devices, the map also is called a translator that will help us to convert the that to our where we start, what we want to start from, and where we want to go to end from. For instance, now let's say our port value. For instance, is go to what map the starting from, since it's ADC, where are we reading from? Readings. Then we have our value. ADC is 10 bit, start from 0 to 1023, that is 1124, 1024 bit. Then we have how many LED do we have here? Our target here is 8 LED, 1, 2, 3, 4, 5, 6, 7, 8. Then we're having 8-bit output outside the buzzer. We'll have the buzzer configuration separately. Then we move from then we have this that's from 0 to what? To 8. It's going to stop at 7. So to 8. So then we also have the bus pin, our bus pin as well. That the bus, maybe bus value is just something like this. Go to what? Map equals map readings of also 0. We want the sound to also increases as the volume increases. So let's try this. 1023. Also the value, okay, analog grade is 8-bit by default, so we don't need digital value from it. So it's 8-bit, so we can easily move from size 256. 2 is to power 8, 8 is 256. We start from 0. That's for our PWM. Start from 0 to 255. Then that is it. Okay. Now we also want to move through it. Want to iterate through the LEDs so that we iterate through them. Then we get the values. Then we also, if we're able to do the for the else if we're able to do the one for the increase of the light, then we're going to solve the problem for the busing for int, for I, for instance. Let's just make use of I less than, yes, I less than, that's the length we have here, I plus. So we're going to do is if sorry, I think I have something. I also have the code here written sometimes because I have an issue on the way as I go. So before then, I think some due I'm still on the way. So have if 0, for instance, if I is less than or equal to what's 8. just is, for instance, of the length. Let's just make it of the length of the values. Let me make it okay, let me read of the port values here. Let's just make it of the port values here. So the same value. I'm not going beyond what we are reading. Then we have we want to display the volume. We want to display the LED digital write first of LED pins of the eye. Want to turn on the first index as it go on based on our readings port value. Then we make it out I. Remember digital write show you whether 0 or 1. I means 1, you should make it I. And it is I because in our circuit diagram here, we grounded the cathode and the anode is connected to the positive. So we expect high voltage from here. Assuming we did it the other way around, where cathode is connected other way and the anode is connected to the positive voltage source. That means the low signal will turn on the LED. So you can try that on your own side hobby. So also try that on your own for exercise. Then what's it called? Then we have it this way. Then we we turn what digital write of LED pins of I to be low, also be 0. So let's also get the value here from the serial terminal. Serial dot write. They want to get the value of the port values. We want to get our values. Function is pointing out from port value. So we want to know which value are we. Then the same thing. Let's get what serial dot port value. That's right. That is our port value. So then I have to, for smooth transition, let me delay for like maybe 10 nanoseconds here in case of delay 10. 1000, if I put 1000 that'll be 1 second. So where my time, so this is in milliseconds. So 10 nanoseconds. So or 10 milliseconds. So for 10 milliseconds, I will get what? So I want to, for smooth transition. Now let me try to compile this in case there is no error. Let me save this. Just inside this folder, and then unlock demo 2. Let me just unlock 2. Then we have our maybe lab, just lab code, just save this. Then I'll compile this. Done compiling. Wow, fine, no error. Then let me, in case you connected your device to it, you can just upload straight to the code. But since I also export the code, because if we check one of our code here, for instance, it's not going to be inside the where is it located? It's not going to be, our code is not going to be present inside our build file. It's going to be inside the temporary file. For that sake, to export the code to our file where the folder is, just come to what? Export here, export compile binary. That's our .x file. It has exported now. So then we can easily come here and load. Right click on this, and also main menu, load firmware. We are going to load the firmware here. So from here, we have Arduino projects, then unlock 2, lab code, Then we come to the S file. We look at the S file. Can you see? Now let's try to run it. Good. So first it's starting from 0, 0. And you see, we have the lighting display. Okay, fine. Here. So we lost one, so it's not starting. It should not start from that area first. It should start from, let's try what you can do to the code. Where is it? Just try to do something here. Just to firstly output 0, that is digital lights of LED pins of first 0 or LED pins. I want to clear the pin first, it will LED pins equal to what? Maybe 0. Okay, for the first instance, so that is low. So let me just clear it to make it something. Then after that, let me compile again. It will work. We should not have the first one coming in. Then export. Anytime you compile, you export the compile binary. Then you can now also reload. You can reload the firmware. Then we can start all over again. Wow, getting 0. So you can also troubleshoot that error to make sure that we don't have digital. Okay, I'm coming. Okay, I have my potentiometer here. Okay, it's not still working, so you can troubleshoot that and fix that. But let's try to fix the sound so you can also hear the sound as it goes. So then we also have the sound here. So this one's not working. So we have the sound here. Then this one is going to be not digital, it's going to be analog, analog, right? Then we have our what? Bus pin, our bus pin. We're writing to our bus pin to what? Our bus values. We get our bus value from here because from here just bus value. So then we also have what? Maybe I digital, no, analog, right? Bus, so bus pins. Then we have bus value or something, just depending on that. So let me just compile this and let's see what is going to be. Export the compile binary, then we can just stop and reload. Then reload this, reload the firmware, just run it. And you see, we are getting the sound. And see, it goes down. So we get the sound and we also increase it back. And you see, so we have it now working, but also let's open our terminal here. You can see as we open, you can see that it will increase the, we are seeing some character display here. We cannot see the value. Let's change it to decimal. Where is it? Decimal value. Can you see? We're able to see the value. Can you see? You can see them changing. We're able to see what it's sending. So now we are through with it. So but not so let's try to just use the PIC sim laboratory to do it fast. It's not going to take us a long time. Now let's try to see it. But here is Arduino code, but my pin configuration is different. But I could easily come to my PIC sim laboratory. We talked about it also in our previous lectures. So then I can also change the board to Nano. I've changed the board to Nano. Now I have a Nano board, my pin laboratory, my Nano board. Then I have my come to tools, come to modus, spare parts. I need to, it's already costing one of the one I tested. So let me just clear. move, delete. Let's delete. So also delete this. We have output. Which one are the input? Which one are the output? The input here is going to be our what? Our potentiometer with rotatory. You can select the value to be only one properties and select one value. Select one. So okay. Okay. Then properties. How many values? That is only one. We need only one rotatory something here. Then this is the input. We also have our buzzer as well. Our buzzer as well. We also have our buzzer. We put it outside here. So, but also we also have our what output LEDs. Then our LEDs, because we have 8 LED here already. We can also increase it based on what we need. Then we right click and configure the pins. Which pin is suited for? We have pin 2 to 9 for our 8D. This is pin 2 is here. This is pin 3. Why is pin 3? You can see the 3 here. The last one is a pulse width modulation. Then we have also pin 4, pin 5, pin 6, pin 7, pin 8. Why is the pin 8? Pin 8, pin 8, pin 9, and that's all. So we have all the pin 9 here. Okay, we're okay here. Then if we rotate and we set this one to the input, it's not going to work now. But because if we rotate it here like this, nothing changes because we have not even loaded the firmware, so nothing changes. Then let's configure. Let's configure this to be the input. Then which pin is the? Let's check for my circuit. A0 is our input file. So let's come to it. Let's come to A0 is the input. A0. Port 1, we only use port 1, and it's A0, A0 is the input. So we okay. Then let's come back to it. Okay. Now, because I'm able to rotate it, can you see I'm able to get the values. We're able to get the values with it. Because we have not loaded the hex file because I want demonstrated it. You can come here to load the hex file, load the hex file, come to lab 3 and lab 2, then Arduino X file, then we should be, let me bring down my, okay, now you see it's already running, so it's still working. So that's it. That is the end of the video. Please like, share, subscribe. Please drop any comment or any question you have in the comment sections. I would love to answer it. Have a wonderful day ahead. Sorry for the video being long. Bye bye.